Chapter 2 Fractions. Fractions, the number of the form a upon b, where b not equal to 0 and ab are whole numbers, is called a fraction. Here, a is called the numerator and b is called the denominator. Types of fractions. Proper fraction. If the numerator is smaller than the denominator, then the fraction is called proper fraction. Examples: 1 upon 3, 4 upon 5, 3 upon 7, etc. Improper fraction. If the numerator is greater than or equal to the denominator, then the fraction is called improper fraction. Examples: 5 upon 3, 7 upon 2, 6 upon 5, etc. Like fractions. Fractions with same denominators are called like fractions. Examples: 2 upon 7, 3 upon 7, 5 upon 7, 6 upon 7, etc. Unlike fractions. Fractions with different denominators are called unlike fractions. Examples: 1 upon 2, 5 upon 7, 4 upon 9, etc. Unit fractions. Fractions whose numerator is always 1 are called unit fractions. Examples: 1 upon 3, 1 upon 5, 1 upon 7, 1 upon 9, etc. Mixed fractions. Fractions having whole number along with proper fraction are known as mixed fractions. Examples: 1 and 2 upon 3, 1 and 4 upon 5, 2 and 2 upon 3, etc. Decimal fractions. Fractions having denominators as 10, 100, 1000, etc. are called decimal fractions. Examples: 7 upon 10, 3 upon 100, 41 upon 1000, etc. Equivalent fractions. A given fraction and fraction obtained by multiplying or dividing its numerator and denominator by the same non-zero number are called equivalent fractions. Examples: 2 upon 3, 4 upon 6, 6 upon 9, 8 upon 12 are equivalent fractions. Vulgar fractions. A fraction whose denominator is a whole number other than 10, 100, 1000, etc. is called a vulgar fraction. Examples: 7 upon 8, 3 upon 17, 19 upon 20, 23 upon 39, etc. Example 1. Convert each of the following into an improper fraction: 1 and 4 upon 5, 3 and 2 upon 7. Solution: 1 and 4 upon 5 is equal to 1 into 5 plus 4 upon 5, which is equal to 5 plus 4 upon 5, which is equal to 9 upon 5. 3 and 2 upon 7 is equal to 3 into 7 plus 2 upon 7 is equal to 21 plus 2 upon 7, which is equal to 23 upon 7. Example 2. Convert each of the following into a mixed fraction: 49 upon 5, 68 upon 9. Solution: on dividing 49 by 5, we get quotient as 9 and remainder as 4. Therefore, 49 upon 5 is equal to 9 and 4 upon 5. On dividing 68 by 9, we get quotient as 7 and remainder as 5. Therefore, 68 upon 9 is equal to 7 and 5 upon 9. Comparison of fractions. Rule 1. When the fractions have same denominators, then the fraction with larger numerator is larger. Examples: 9 upon 11 greater than 7 upon 11. 3 upon 8 greater than 1 upon 8. 5 upon 7 greater than 3 upon 7. Rule 2. When fractions have same numerators, then the fraction with larger denominator is smaller. Examples: 3 upon 7 less than 3 upon 5. 7 upon 11 less than 7 upon 9. 5 upon 14 less than 5 upon 12. Rule 3. When fractions have different denominators and numerators, then we multiply or divide the fractions with the same number to make denominator same and then apply Rule 1. Example: which is greater, 3 upon 5 or 7 upon 8? Solution: LCM of denominators 5 and 8 is 40. Therefore, 3 upon 5 is equal to 3 into 8 upon 5 into 8, which is equal to 24 upon 40. 7 upon 8 is equal to 7 into 5 upon 8 into 5, which is equal to 35 upon 40. Now, 35 upon 40 greater than 24 upon 40. Hence, 7 upon 8 greater than 3 upon 5. Alternative method. Cross multiplication method. To compare 3 upon 5 and 7 upon 8 by cross multiplication method, we write 3 upon 5, 7 upon 8. Cross 3 into 8, 7 into 5, 24, 35. Since 35 greater than 24, hence 7 upon 8 greater than 3 upon 5. Lowest terms of a fraction. A fraction a upon b is said to be in lowest terms irreducible if HCF of a and b is 1. Any fraction may be reduced to lowest terms by dividing the numerator and denominator by their HCF. Example 1. Reduce the following fractions to their lowest terms. 78 upon 338. Solution. HCF of 78 and 338 is 26. Therefore, 78 upon 338 is equal to 78 divided by 26 upon 338 divided by 26, which is equal to 3 upon 13. 78 upon 338 in its lowest terms is equal to 3 upon 13. Example 2. Arrange the following fractions in ascending order. 1 upon 3, 2 upon 5, 5 upon 6, 1 upon 15. Solution. LCM of 3, 5, 6 and 15 is equal to 3 into 5 into 2, which is equal to 30. 1 upon 3 is equal to 1 into 10 upon 3 into 10, which is equal to 10 upon 30. 2 upon 5 is equal to 2 into 6 upon 5 into 6, which is equal to 12 upon 30. 5 upon 6 is equal to 5 into 5 upon 6 into 5, which is equal to 25 upon 30. 1 upon 15 is equal to 1 into 2 upon 15 into 2, which is equal to 2 upon 30. Therefore, the denominators are same, so the fractions having the greater numerator is greater. Therefore, 2 upon 30, 10 upon 30, 12 upon 30, 25 upon 30 are in ascending order. This implies 1 upon 15, 1 upon 3, 2 upon 5, 5 upon 6 are in ascending order. Addition and subtraction of fractions. Rule 1. In order to add or subtract like fractions, we add or subtract their numerators and retain the common denominator. Example 1. Simplify 8 upon 15 plus 7 upon 15, 9 upon 10 plus 6 upon 10. Solution. 8 upon 15 plus 7 upon 15 is equal to 8 plus 7 upon 15, which is equal to 15 upon 15, which is equal to 1. 9 upon 10 plus 6 upon 10 is equal to 9 plus 6 upon 10, which is equal to 15 upon 10, which is equal to 3 upon 2. Rule 2. Fractions with different denominators can be added or subtracted by changing the given fractions to equivalent fractions having same denominator. Example 2. Simplify 2 upon 9 plus 2 upon 3, 3 upon 10 plus 1 upon 2. Solution. 2 upon 9 plus 2 upon 3 is equal to 2 upon 9 plus 2 upon 3 into 3 upon 3, which is equal to 2 upon 9 plus 6 upon 9, which is equal to 2 plus 6 upon 9, which is equal to 8 upon 9. 3 upon 10 plus 1 upon 2 is equal to 3 upon 10 plus 1 upon 2 into 5 upon 5, which is equal to 3 upon 10 plus 5 upon 10, which is equal to 3 plus 5 upon 10, which is equal to 8 upon 10, which is equal to 4 upon 5. Alternative method for addition and subtraction. The addition and subtraction of fractions with different denominators can also be performed as follows. 7 upon 20 plus 13 upon 35. LCM of denominators 20 and 35 is 140. 7 upon 20 plus 13 upon 35 is equal to 7 into 7 plus 13 into 4 upon 140. 140 divided by 20 is equal to 7 and 7 into 7 is equal to 49. 140 divided by 35 is equal to 4 and 13 into 4 is equal to 52, which is equal to 49 plus 52 upon 140, which is equal to 101 upon 140. 8 upon 9 minus 7 upon 12. LCM of denominators 9 and 12 is 36. 8 upon 9 minus 7 upon 12 is equal to 8 into 4 minus 7 into 3 upon 36. 36 divided by 9 is equal to 4. 8 into 4 is equal to 32. 36 divided by 12 is equal to 3. 7 into 3 is equal to 21. This is equal to 32 minus 21 upon 36, which is equal to 11 upon 36. Multiplication of fractions. To multiply one fraction by another, we multiply the numerators together to get the numerator of the product and multiply the denominators together to get the denominator of the product. Thus, if A upon B and C upon D are two fractions, then A upon B into C upon D is equal to A into C upon B into D. That is, product of fractions is equal to product of their numerators upon product of their denominators. Example 1. Multiply and reduce the following fractions into their lowest form and convert them into mixed fractions. 5 into 4 upon 9, 2 upon 3 into 4. Solution. 5 into 4 upon 9 is equal to 5 upon 1 into 4 upon 9, which is equal to 5 into 4 upon 1 into 9, which is equal to 20 upon 9, which is equal to 2 and 2 upon 9. 2 upon 3 into 4 is equal to 2 upon 3 into 4 upon 1, which is equal to 2 into 4 upon 3 into 1, which is equal to 8 upon 3, which is equal to 2 and 2 upon 3. Example 2. Multiply and express each of the following as a mixed fraction. 5 into 3 and 2 upon 5, 3 and 1 upon 6 into 15. Solution. 5 into 3 and 2 upon 5 is equal to 17. 3 and 1 upon 6 into 15 is equal to 95 upon 2, which is equal to 47 and 1 upon 2. Fraction as an operator of. Observe the adjacent figures. These are two exactly similar squares. Each shaded portion represents half of one square, that is, 1 upon 2 of 1. Both the shaded portions together will represent half of 2. If we combine the two shaded half parts, it represents 1. That is, 1 upon 2 of 2 is 1. This implies half of 2 is equal to 1. Also, half into 2 is equal to 1. We see that of represents multiplication. Here are some examples using an operator of. 1 upon 2 of 4 is equal to 1 upon 2 into 4, which is equal to 2. 1 upon 2 of 5 is equal to 1 upon 2 into 5, which is equal to 5 upon 2. 1 upon 2 of 6 is equal to 1 upon 2 into 6, which is equal to 3. 1 upon 2 of 7 is equal to 1 upon 2 into 7, which is equal to 7 upon 2. Example 4. Find 2 upon 3 of 81. 5 upon 7 of 98. Solution. 1. 2 upon 3 of 81 is equal to 2 upon 3 of 81 upon 1, which is equal to 2 upon 3 into 81 upon 1, which is equal to 2 into 27, which is equal to 54. 2. 5 upon 7 of 98 is equal to 5 upon 7 of 98 upon 1, which is equal to 5 upon 7 into 98 upon 1, which is equal to 5 into 14, which is equal to 70. Value of the products. We know that the product of